Hi class, today's lesson is 11-4, Transformations in the Coordinate Plane. Go ahead and take a look at our purpose. Our purpose is to use translations, reflections, and rotations to change positions of figures in a coordinate plane. We've already worked with translations, reflections, and rotations in a previous unit, so this should not be, it should be pretty familiar to you. Vocabulary, there's no new vocabulary, although it'd be a good idea to review those definitions in the back of your book that we already wrote about: translations, reflections, and rotations. Let's take a look at our first example. Our first example asks us to translate square ABCD, right here, 6 units to the left. Translate. Remember, translate means it just means moving a particular figure, in this case a square, moving it in one direction, and that direction is linear. If I were to take this square and superimpose it on square ABCD, when I translate it, I would essentially move it. Here I'm moving it 6 units to the left. So if you just look at this leading edge and watch, you can see that I'm moving it 1, 2, 3, 4, 5, and then 6. And I land in this new square. Notice that the designation for this new place is also A, B, C, D, but it has this little apostrophe. Now that apostrophe we call prime. So this is A prime, B prime, C prime, D prime. All it means is it's essentially just the translation or the movement of that initial square. How do we do that? When we translate something, the easiest way to do it is not by physically moving the square, of course, but physically moving the vertices, the corners of this square. Here we have A, and this is 1, -1. And we know we're going to move it 6 units over to the left. We move it 1, 2, 3, 4, 5, 6, and we go ahead and make that dot. We'll do the same for B. 1, 2, 3, 4, 5, 6, and so on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That gives us the 4 corners of the square, and then all we need to do is draw the lines. So the this coordinate plane gives us the opportunity to locate the corners and then follow through by connecting the dots. Let's go to the second example. Second example is about reflection. It says reflect triangle ABC across the y-axis. Give the coordinates of each vertex in the image. That's something we forgot to do in the last example, but we're going to go ahead and make sure that we do give the coordinates of each of the vertexes, or vertices, I should say. Here we have triangle ABC. Okay. We're going to reflect it, which means we're essentially going to flip it over to its mirror image on the other side of what? The y-axis here. Here's the y-axis, and what we do is we find out, well, how far is point A, away from this vertice, and I'm sorry, away from the axis, the y-axis, and we see that it is 1, 2. So we go in that same direction, in the other go in that same way in the other direction across the y-axis. We have 2 spaces over, and we label that A prime. We go down to the B. We see that it is 2 away from the y-axis, so we do the same on the other side, and we locate the vertex there. C is 1, 2, 3, 4 away. 1, 2, 3, 4. Now we've got the 3 vertices of the triangle. We go ahead and take a straight edge and draw lines connecting the dots, and we have our reflected triangle. Now notice that the y-axis is also called the line of reflection. Okay. When we are finished, we come out with the coordinates for A prime, B prime, and C prime. Those coordinates, remember, I go to get to A, I go over 2, that's a -2, and up 4. -2, 4. For B, or B prime, it is over -2, up 1. -2, 1. Finally, for C prime, it is 1, 2, 3, 4. That's -4, and then up 1. -4, 1. Those are the 3 vertices of the triangle. That's a reflection of the original. We're continuing. I'm going to go ahead and skip over example 3. It's the same sort of concept. I don't want you to actually take notes on this, other than to see that we can reflect horizontally as well. Here, the triangle XYZ needs to be reflected across the x-axis, the horizontal axis, of course. So we do essentially the same thing. We locate how far these different vertices are from the x-axis and translate that information to the vertices on the other side, the reflected image. Okay, so don't worry about drawing this one out. I do want you to go ahead and draw this out, though. It's the rotation. This is the third type of transformation that we can make. Here it asks us to rotate rectangle PQRS 90 degrees clockwise about the origin. Give the coordinates of each vertex in the image. So I'm going to go ahead and take this rectangle and superimpose it upon rectangle PQRS. So you can see what we're doing. It asks us to rotate this thing 90 degrees clockwise. Okay, 90 degrees clockwise means we're moving down, and it's going to be clockwise about the origin. That means the point of rotation is 0, 0 on the coordinate plane. See how we rotated it down? See how 0, 0, or the origin, is the place of rotation. So we just rotated it 90 degrees there. So how do we get there when we really don't have anything to rotate on paper? So what we do is we're going to go ahead and start with P. Where's P prime? Well, P prime is going to be on the origin as well, because that's the point of origin. So that does not, actually that's a point of rotation, so that does not change at all. Point S, however, changes. We see that it is distance 4 units away from the origin, and when we rotate this, it's going to be 4 units away from the origin once again. 1, 2, 3. I'm sorry, it's 3 units. 1, 2, 3 from the origin to S, and 1, 2, 3 from the origin to the rotated figure. Then for R, we see that we need to move that from S 4 units. 1, 2, 3, 4. It's going to be downward, so 1, 2, 3, 4, straight down. Boom, we have R. From R to Q, it's 3 units, and we should find ourselves back against the axis. In this case, the y-axis. 1, 2, 3, we're up against the y-axis. We've just completed finding out where those vertices are. We just rotated, essentially, that square. Now, this is what I want you to do. I want you to go ahead and draw this coordinate plane, 2 number lines, vertical, horizontal, the x-axis and the y-axis. Draw this square. And what I want you to go ahead and do is reflect that square over the x-axis. So where are you reflecting it over? You're reflecting, you're reflecting this square over this axis by essentially flipping it over to the other side over here. All right, we'll see you in class.